TVE Happy Math Hour weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. Let me start the recording. Thank you. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with the information we will be sharing today. I'll go ahead and post the link to the 1324 room. And without further ado, I'll go ahead and pass it to our presenters.
Welcome, everyone, and thank you again for joining us this Friday to do some Happy Math Hour. Let's give a few seconds for those who want to join the Math 1324 room. As mentioned, the link is on your chat. Just go ahead and click on it. Very good. Okay, so for those who are staying behind, we are doing math for the Math 1314, and today's session will be on basic matrix operations and using matrix operations. So in your homework for your Math 1314, this is section 8.1. So my question to you is, what is a matrix? So, and we're not going to be talking about the one with the Keanu Reeves movie with all the letters and numbers coming down your screen, okay? That's not the matrix we are talking about, or the one that we're going to be talking about today. So the matrix that we're going to be talking today is the math matrix, and in the simplest terms, it's going to be a rectangular array of numbers. And the syntax for matrices is going to be denoted by our brackets. Okay, when we have these brackets, we know that we're going to be dealing with a matrix. Okay, so a more formal definition, and the definition that's in your book, it's an array, it's a rectangular array, and it's denoted by these columns and rows. Okay, so when we actually read the matrix, we want to read it by first the rows and then the columns. Okay, so it's always rows by columns, okay, or m by n. Okay? Now, each entry in the matrix is called an element, okay, and each element has an address. So for instance, this element here, A11, this A11 refers to row 1, column 1. So if I look at this one over here, A23, this means that this element is in row 2, column 3. Okay, so this is what the formal definition of a matrix is. Now, matrices in the world, you may not know it, but are used widely. Okay, they're used in video games to create all the graphics, to look for algorithms, to look for patterns. We use matrices. Banks use matrices to encrypt information, to hide information, and hopefully you'll see some of this at work in later sections of this chapter. Okay. All right, so let's first talk about the dimensions of the matrix. So when we hear the dimensions of the matrix, what we're talking about is the size of the matrix. And the size of the matrix is composed of its number of rows and columns. So for example, this matrix here has 2 rows and 2 columns. So its dimension is a 2 by 2 matrix. Now, whenever we have the same number of rows with the same number of columns, we consider that a square matrix. Okay, so if we would have had 3 rows and 3 columns, that also would have been a squared matrix. So a squared matrix is defined by a matrix that has the same number of rows and the same number of columns. Okay, so we also have what's called a row matrix, which is just a row, and one row, and this has 2 columns, but a row matrix only has 1 row. Okay, we also have a column matrix, means that it only has 1 column. But again, when we read this, we read this by the definition of its dimensions. It's always the rows by the column. So this one is row 1, column 2 columns. This is 2 rows, 1 column. Okay. Now this one, this is a squared matrix again, but this is a special matrix. This is called the identity matrix. Whenever we have this 1 0 0 1, okay, this is what's called our identity matrix, and we're going to see several of our identity matrix depending on its size, depending on its dimensions. All right, so let's first look at some examples. Okay, so this problem says determine the dimension of each matrix. Okay, so A here, remember, we always think of the dimensions as rows times column. So we see that we have 1 row, but there are no more elements. So this one would be a 1 by 0. Okay, we only have the 1 row, 0 columns. Let's look at B. Okay, we always think of matrices rows by columns. So on this particular one, we see that we have just a row matrix. Okay, so we have 1, -3, 0, and 1/2. So which one would this be? So we have 1 row and 4 columns. This would relate to C here. Okay, how about this one, C? We have 2 rows, 2 columns, right? So this one would be B. Okay, it's a 2 by 2 matrix. How about D? D, we have 1, 2, 3 rows and 1, 2 columns. So this would be a 3 by 2. So again, this is a 3 by 2 matrix. Okay, so again, very important to understand that the dimensions of a matrix refer to the number of rows by the number of columns, and this signifies its size, the size of a matrix. All right, so an augmented matrix is going to be useful to solve linear systems. So linear systems, we can convert them into what's called matrix form, and the name of this matrix form is called an augmented matrix form. Okay, so here's an example. If we have this linear system, and we should be familiar with linear systems, we saw these in chapter 7. So we have this linear system that is 3x plus 5y equals -9. X plus 4y equals -10. So to convert this linear system into a matrix form, into its augmented matrix form, we're only going to take the coefficients. Okay, so the coefficients of x are 3 and 1. So we have 3 and 1. This is row 1, row 2. Okay, the coefficients of the y's are 5 and 4. So they go here. Now, when we're doing the augmented matrix form on paper, the equal sign refers to this line right here. Okay, so this is the equal sign. So equals, and then for row 1 would be -9. For row 2 would be -10. Now, on your computer, when you see the augmented matrix form, since it's a computer, you're going to see 3 dots instead of a line. Okay, we do a line for paper format, but for the computer on your WebAssign, you're going to see 3 dots. So it's going to be 3, 5, and then 3 dots, -9. You'll see 1, 4, 3 vertical dots, and -10. Okay, and you'll see an example shortly. Okay. So let's do this example. Write the augmented matrix for this system of linear equations. Okay, so we have 1, 2, 3, 4 rows. Okay, so we're going to have 4 rows on our augmented matrix, and we're going to have 1, 2, 3 columns for the variables. Okay, we're going to have our line or our dots for our equal, and we're going to have our solution points. Okay, so let's go ahead and do this. So again, to signify that we are dealing with a matrix, we're going to use brackets. Brackets indicate that we are dealing with a matrix. Again, I already went ahead and put my line here. The line will represent my equal signs. So now I'm just going to get the coefficients of each variable. Okay? All right, so for here, row 1, okay, the x here was 1. And the y is 3. Oh, do you see here that we have I said we had 3 rows and we have 4 rows. Okay, we have the X, Y, Z, and W. Gotta be careful to make sure that we pay attention to that. We see that this row is missing the Z. This row is missing the X. This row is missing the Y, and this row is missing the W. Right? So we gotta pay attention closely to those. So here we have a 1 for the X, 3 for the Y, but this one has no Z, so we're going to use a 0. Here we don't see it, but there's a 1 here, but since the symbol is a negative, so it's going to be a -1. Again, equals 9. Row 2, we don't have an X, so we'll signify that as 0. We have -1, 4, 2 equals -2. The third line, okay, we have 1, we have no Y, so we have 0, -5, -6 equals 0. And the last line, we have 2, 4, -3, we had no W, so it'd be 0 equals 4. So what are the dimensions of this augmented matrix? So we have 4 rows, 1, 2, 3, 4, and the number of columns, 1, 2, 3, 4, 5. So the size of this matrix, or the dimensions of this matrix, is a 4 by 5 matrix. Now please ask any questions if I go too fast, or any questions, please. Okay. Now we can also work backwards. They can give us a augmented matrix form, and awesome, Janice. And we can convert it back to its linear format, the linear equation format. So here's an example of what you see on the computer, okay? You're not gonna see a line, okay? You're going to see 3 vertical dots for each line, okay? So here, I see that I have 2 rows, so I'm gonna have 2 linear equations. To the left of the equal sign, okay, I only have 2 numbers, so that means I'm only gonna use 2 variables, and the convention for the variables is always X and Y. Again, if we have more than 2, then we'll use Y and Z, okay? So on this particular one, we're just gonna use X and Y, but your computer homework will tell you which variables to use, so be very careful with that, okay? All right, so let's go ahead and convert this into its linear equation. So again, we have a 6, so that's gonna be our 6X. We have a 5, so that's gonna be a 5Y, then these are positive. Again, our 3 dots mean equal to, okay? Our second line, or for our second equation, we have a 3. This represents the X. We have a -9, so this would be the -9Y equals 0, okay? So we can go back and forth. Very, very useful information, okay? All right. So this one says, write the system of linear equations represented by the augmented matrix form. So let me give you a second for you guys to work it out. Okay, so on this particular one, we see that we didn't put in the dots, but we should have, okay? We didn't want to trick you, okay? But we would have dots here if I can write. All right, so here, okay, we have 2 rows and we have 3 columns. So we had to include our equal sign, okay, and I do apologize for that. So here we have a variable for number for the first column, but we don't have one for the second. So we are just going to use X. So there's only one X equals 4. Okay. Second row, we don't have an X, but we have a Y. So we have one Y, so it's Y equals 3. Okay. Again, and then this is the syntax for our linear systems. Okay. All right, so we can use, the reason why we were practicing to convert a linear system into a matrix form is because we can solve these linear systems using our matrices. Okay, so first let's look at some terminology as far as to do these row operations. Okay, so when we're dealing with matrices, we are allowed to interchange rows. So, and I'll give you an example. And the syntax that you'll be studying is this double arrow. This means that I want to switch row A with row B. So for instance, if I have a row 1 and I want row 1 to be row 3 and I want row 3 to be row 1, I use this symbol, this double arrow, to interchange rows. Okay. I can also multiply a row by a constant. Okay. I can multiply a number to a row. And we gotta be careful. When we multiply a number to a row, we're gonna multiply it to the whole row, okay? To everything that's left of the zero and everything's to the right of the zero, okay? And we could also add rows together, okay? So we can add multiple rows together. Now, hopefully, this is a little bit familiar. This notation and this syntax, what we're talking about, is precisely what we were doing when we were doing chapter 7. When we were doing methods of addition for solving linear systems, this is precisely the process, but we're going to be using matrices now. So the best way to see this is with an example. So the first thing that you're going to see on your homework, and then they're going to ask you on the homework, is they're going to give you a linear system. And the first thing is, let's convert this linear system into its augmented matrix, form. Okay. So again, we have 2 lines. So we're going to have 2 rows on our matrices. Okay. We have 3 columns, okay, with an equal sign. So to the left of the column, since we only have 2, we're going to have only the 2 variables, which is the x and the y. So let's go ahead and do it. So we have 6, 5 equals 2. Second line, we have 3, -9 equals 0. Okay. So now the next process is what we want to solve this linear system using an matrix form. What we want is to have the identity matrix on this left-hand side. So what we want is we want to convert this into this. And the technical or math name for this is using or having it in reduced echelon form. Okay. Now, all the examples that I'm going to do here today, I'm going to show you how to do this by hand. But some of you might have seen this name on your graphing calculators. Okay. Your graphing calculator will help you simplify matrices. Okay. But for our section, I'm going to show you how to do them by hand. Okay, so let's get to it. All right, so let me give you an example of interchanging rows. Okay, so if you see this matrix here, I have row 1 is 0, 1, 3, 4, and I have row 2 -1, 2, 0, 3. So what I can do, I can say row 1, I want to interchange that with row 2. And what's going to happen is when I do this syntax to this matrix, to my original matrix, it becomes this. Okay. My row 2 now becomes my row 1. You see, I have -1, 2, 0, and 3. And my row 2 now is 0, 1, 3, 4. Okay. This is what happens when we interchange rows. Okay. Again, this is the syntax. All right. So now let's look at the other process that we can do to matrix. We can multiply a constant, a number to a row. So do you see here on my syntax, I'm saying that I'm going to multiply a 1/2 to row 1. So when I do that, okay, I'm going to multiply this 1/2 to all the numbers, okay, of this. This was the original. I'm going to multiply this 1/2 to all the numbers here. So 1/2 times 2 is going to give me 1. 1/2 times a -4, it's going to give me a -2. 1/2 times 6 is going to give me a 3. A 1/2 times a -2 is going to give me a -1. Again, this is the syntax. I'm multiplying a 1/2 to row 1, and it's going to give me a new row 1. Okay. Now, the last example is to add two matrices together. So we see here the syntax here is we're combining it also with multiplying a constant. I want to multiply a -2 to row 1, and I'm going to add that to row 3 to get a new row 3. Okay, so my original matrix for the row 1 is 1, 2, -4, 3. Now let me go ahead and do that because I skipped that step, but let me go ahead and multiply this -2 to the row 1. And I'm going to do a little scratch work here, and let me change the color as well. So if I multiply -2 to row 1, I get 1 times a -2 is a -2. Okay? -2 times a 2 is a -4. A -2 times a -4 is a +8. And a -2 times a 3 is a -6. Okay? And it's saying that I want to add this to row 3. This is my row 3 right here. So I'm going to add this to row 3. So row 3 is 2, 1, 5, and -2. So when I add these two rows together, -2 plus 2 is 0, which is what I have there. -4 plus 1 is a -3, which is what I have there. Okay. 8 plus 5 is 13. -6 plus -2 is a -8. So this is an example of how to add two matrices together. And the syntax, I'm multiplying first a number to row 1, and I'm adding it to row 3 to get a new row 3. Okay. All right, and this is always the format. The single arrow definition is the new row that you are getting with depending on the operation. So you see here, I am getting I'm multiplying a 1/2 to row 1 to get a new row 1. All right. So let's go ahead and see an example. Let's use matrices to solve this linear system. And so we have 2x plus 4y equals 8 and x minus y equals 5. So the first thing we need to do is convert it into its augmented matrix. Okay. All right. So here we have two lines. So we're gonna have two rows. Okay. So we have 2, 4 equals 8. We have 1, -1 equals 5. Okay? So now what we want to do in order for us to solve this, our goal is to get this. We want to have our left side of the equal. Okay, we have the equal right here. We want this to look like our identity matrix. 1, 0, 0, 1. Now, why is that? Why do we want this to look like this? Well, what this is telling us is that, remember, this row, this element here refers to the x. This column refers to the y. So what this is telling me is that 1x is going to be equal to this number over here that's referred to a. On this row 2, I'm not interested in x anymore. I want to know what the y value is. So I have 1y is going to be equal to this b here. Okay, and in order for us to do this, we're going to do row reduction elimination. Okay, to get it into what's called row echelon form. Okay, all right, so let's go ahead and do this. So the first thing that I want to do is I want to go in order. Okay, so this is very, 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 very important that when you are doing these row operations, you always want to go from left to right. Okay, and you want to go column by column. If you go at a different pattern, you'll go in circles and you'll never solve it. It could get very, very confusing. So make sure that you always go from left to right, and you're always doing you're going column by column. So the first thing that I want to do is this problem is because I want a 1 here, okay, I'm going to use my property of swapping rows or switching rows. I want my row 2 to become my row 1 to become row 2 and row 1 become row 2. So again, my syntax here is row 1 with a double arrow row 2. So now I have this 1 negative 1 equals 5, 2 4 equals 8. Okay. Now the next thing that I want is, since I have a 1 here, now I want a 0 here. So what I'm going to do is I'm going to multiply a negative 2 to row 1, and I want to multiply a negative 2 in order for me to, when I add these two rows together, I want to cancel out the 2. So what is opposite of 2 is a negative 2. So when I multiply negative 2 times 1, it's going to give me a negative 2. When I multiply a negative 2 times a negative 1, that's a positive 2. And when I multiply a 2 times 5, it's going to give me a negative 10. But let me show you the process here where we got the 0. So again, when I multiply the negative 2 times 1 is a negative 2. Negative 2 plus 2 is 0. That goes there. Okay? Then I do it again. Negative 2 times a negative 1 is a positive 2. And I'm going to add the 2 plus the 4 is going to give me 6. Okay. Then again, negative 2 times 5 is a negative 10. Negative 10 plus 8 is a negative 2. Okay. So you see, I'm at the right track. Okay. I have a 1 0 here. Now what do I want is I want a 0 here and I want a 1 here. Okay. So let's continue with our row operations. So what I'm going to do is I am going to multiply a constant to row 2. I'm going to multiply 1 6 to row 2, because what I see is if I make this into a 1, okay, it's opposite to a negative 1 already, and then all we'll have to do is just add row 1s with row 2. Okay, so let's go ahead and do this operation. I want to multiply a 1 6 to row 2, and that's going to give me a new row 2. Now, also, I like to tell my students, you see that I'm only dealing with row 2. So before I get started, I like to write row 1, because row 1, I'm not touching it. So, and that way I don't do silly mistakes. I'll write that first. Before I start this operation, I'm going to write row 1, because that one, I'm not touching it. I'm not doing anything to it yet. So I would write 1 negative 1 equals 5. Okay. And then I start working with this, multiplying the 1 6 to row 2. Okay, so if you see, when I multiply 1 6 times 0, that's going to give me 0, and 0 plus 1 will be 1. Okay, 1 6 times 6 is going to be 1. Yes, so and then when I add these, it's going to give me 0. 1 6 times a negative 2, okay, that's going to give me a negative 1/3. And when I add that to the 5, okay, we're going to get a negative 1/3. Okay, so hopefully you're following my steps. What I want to do is I want to get this side to become my identity matrix. So now that I have this from my multiplication, now I'm going to add my rows. I'm going to add row 2 with row 1 to get my new row 1, because I want a 0 here now. So I don't have to multiply anything. So you see here, if I add 0 plus 1, it's going to give me the 1, and 1 minus 1 is going to give me the 0, right? So let me show you. Okay, a 0 plus 1 is the 1. 1 minus 1 is a 0, and negative 1/3 plus 5 is 14/3. And I keep forgetting the equal sign. Okay, all right. So what this says, okay, what this is telling me is that the x value is equal to 14/3, and the y value is equal to negative 1/3. So instead of using what we had learned before in chapter 7, you know, the substitution or addition by elimination, Now we can use matrices to solve. Now I know what you're saying. Okay, this seems a lot more work than using the substitution or elimination method. But would you want to do the substitution elimination method for 3, 4, 5 lines, 5 linear systems? So matrices will help you when we have more lines. Okay, right now it looks like a lot of work, but matrices do help us better solve linear systems. Okay, so let's continue practicing. Okay, let's solve this um, matrix or linear system. Okay, again, they already have it in our augmented matrix form. We have -3, 4 equals 22. We have 6, -4 equals -28, 8. And again, the goal is to make our elements on the left side of the equal be our identity matrix, 1, 0, 0, 1. All right, so let's get started. So I don't want to swap. It doesn't help me swapping anything. So let's go ahead and reduce this row 2 to get it into a 3. And I see that if I multiply a -1/3, well, actually we can go the long way. Let's make this into a 1. Okay, let's make the row 1, this column, this first element in row 1, column 1, a 1. So I'll do that by multiplying a -1/3 to row 1. And again, this should have been just a single arrow, not a double arrow. Just single arrow, it's going to give me my new row 1. So if I do that, okay, -1/3 times a -3. So a -3 divided by a -3 is a +1. A -1/3 times 4 is a -4/3. And a -1/3 times a +22 is a -22/3. Okay, so I have a 1 here. Now, there's several ways of doing these. Okay, this is just one way. When I first looked at this problem, I was going to go at it a different way. But again, there's many ways of solving. There's no wrong way of starting or doing these matrices. Okay, as long as you go in order, as long as you go from left to right and column by column first. Okay, all right. Now that I have my 1 here, let's go ahead and get my 0 here. So to eliminate this 6, I would have to have a -6 here. So that's precisely what I'm going to do. I'm going to multiply a -6 to row 1, and I'm going to add that to row 2. And again, a mistake again, this should only be a single arrow. It's going to give me my new row 2. Okay, so again, since I think you guys are familiar, skipping some steps, but again, I multiplied a -6 times 1. That gives me -6. And multiply -6 times -4/3. And again, to get my new row 2. So, oh, I did have them, sorry. So let me start again. So when I multiply -6 times row 1 is a -6. -6 plus 6 is 0. Okay. Here, when I multiply a -6 times a -4/3, okay, it's going to give me 8 minus 4, which is going to be 4. And when I multiply a -6 to a -22/3, it's going to give me 44 minus the 28, which is going to be 16. Okay, so now that I have this, again, what I want now is I want a 1 here, and I want a 0 here. Okay, so we're going to continue with our row operations. So to do that, okay, the first thing that I'm going to do is I'm going to get the 1 here, and I can get that by multiplying a 1/4 to row 2. Okay, so when I do that, 1/4 times 0, that's 0. 1/4 times 4, so 4 divided by 4 is 1. And 1/4 times 16, or 16 divided by 4, is 4. So I got my 1. So now what I want is to get a 0 here. So to do that, I'm going to multiply a positive 4/3 to row 2. And I'm going to add that to row 1 to get my new row 1. Okay, again, rule of thumb, I'm not touching my row 2, so that's the first thing that I want to write. I want to write my row 2 because I'm not touching that. What I'm getting is a new row 1. So let's go ahead and do that. When I multiply 4/3 times row 2, so 4/3 times 0, that's 0. Okay, 0 plus 1 is the 1. Okay, then we have a 4/3 times 1 is 4/3. 4/3 minus 4/3 equals 0. And then we have 4/3 times 4, that's 16/3 minus a 22/3 is going to give me a -2. Okay, so you see now that we have 1, 0, 0, y. So again, we have the x value with no y. So our x is equal to -2. We have no x value for row 1, but this is our y value, and our y value is equal to 4. Okay? So this is using matrices to solve linear systems. Okay? All right, so let's go to section 8.2. Okay, now that we know how to solve for linear system using matrices, let's do basic operations with matrices. Okay, so the first thing that we need to do is do a little review as far as our matrices. So two matrices are equal when they have the same dimensions and corresponding entries. What that means is two matrices are equal if they are the same size and they have the same elements inside the matrix. That's what makes them equal. Okay. Now, to be able to add two matrices together, they have to be the same size. They have to have the same dimensions. In order for us to add two matrices, we have to be able to add each element with each corresponding element, okay, of each matrix. We could also multiply a value to a matrix, and when we do that, we got to make sure that this constant is multiplied to each element in the matrix. Okay? And we'll see an example of that. We're also going to be subtracting matrices together. And again, in order for us to subtract matrices together, they have to have the same size. They have to have the same dimensions in order for us to subtract matrices together. Now, keep in mind, when we give uppercase letters, what this means is we have matrix A and matrix B. So when we're subtracting matrix A with matrix B, you can think of this negative or the subtraction symbol as a scalar multiplication to matrix B. We're multiplying a -1 to all of the elements in matrix B. Okay? And we'll see an example. All right, so let's start with an easy one. Let's start with the scalar multiplication. So do you see we have two matrices here? We have matrix A. If you see here, this matrix, its size is a 3 rows by 3 columns. So the dimensions of this matrix is a 3 by 3. Matrix B, this is 3 rows, 3 columns. So the dimensions of this matrix is a 3 by 3. So okay, so we know that they are the same size, so we'll be able to add them and we'll be able to subtract them because they are the same size. But let's do this first. Let's do A. Let's multiply 3 times A. So we're multiplying a scalar value to matrix A. So what that means is this 3 is being multiplied to this matrix, 2, 2, 4, -3, 0, -1, 2, 1, 2. So this 3 has to be multiplied to each element in the matrix. Okay, so we have 3 times 2, 3 times 2, 3 times 4, 3 times -3, and so on. Okay, so our answer for 3A is 6, 6, 12, -9, 0, -3, 6, 3, 6. Okay, we multiplied this 3 to every element in the matrix. All right, so let's practice when we're going to be subtracting. Okay, so if I have a negative B, okay, keep in mind it's like if we were multiplying a -1 to our matrix B. So it could be a scalar multiplication. So let's go ahead and do this. So when we do this, we multiply this -1 to all of the elements in here. You get -2, 0, 0, -1, +4, -3, +1, -3, and -2. Okay, and we can combine these processes. What would be 3a minus b? Okay, so the first thing is, again, we can do this. Why? Because they are the same size matrix. We are dealing with a 3 by 3 matrix and a 3 by 3 matrix. Since they both have the same dimensions, we can do this subtraction. So this is the answer that we got for 3a. And this is what we got for the -b. So we're just going to add the two matrices together. So when we're adding matrices together, it's element with element, and it corresponds to their address of the element. So this is element row 1, column 1 has to be added with row 1, column 1 of the other matrix. Okay, so it's element with element. So you see here, we're going to add 6 plus a -2 is going to give me a 4. 6 plus 0 is 6. 12 plus 0 is 12. -9 plus a -1 is a -10. 0 plus 4 is 4. -3 plus -3 is a -6. 6 plus 1 is 7. 3 plus -3 is 0. And 6 plus -2 is 4. Okay, it's each element with its corresponding address. Okay, so this last one was row 3, column 3 has to be added with row 3, column 3 of the other matrix. Okay, any questions on these? Okay, all right, so let's continue. Awesome, Janice. All right, so let's look at an example right off your homework. Okay, so this is what you see. So it says, if possible, find a plus b, a minus b, then 3a, and then we want to combine. We want to do 3a minus 2b. Okay, all right, so let's do this first one, a plus b. But before we do that, okay, is it possible, in order for us to add matrices together, they have to have the same dimensions? So if I look at matrix A, the dimensions of matrix A has 2 rows, so that's 2. So A, the size of A is 2 rows by how many columns? 1, 2, 3. 3 columns. Now let's look at B. Okay, B also has 2 rows. But how many columns does matrix B have? It only has 2 columns. So again, for us to be able to add matrices together, they have to have the same dimensions. And clearly, these do not have the same dimensions. So the answer for this would be impossible. Okay, these matrices do not have the same order. So what you would put on your computer is impossible. Okay. All right. How about this one? Solve for x and y. Okay, so here we have this matrix, x -4, 6, 21. Is equal to this other matrix, -3, -4, 6, y. And as before, what we talked about, for two matrices to be equal to each other, first they have to have the same dimensions. But they also have to have the same elements. So here, this x is unknown, but the x on this one, on row 1, column 1, is a -3. So that means that x has to be equal to a -3. Here, this y value, this row 2, column 2 value is a 21. So this y value has to be the same as this one for them to be equal. So y equals 21. Okay. Let's look at this one over here. It's a little bit more complicated. So we have 2 rows and 1, 2, 3, 4 columns. This matrix has 1, 2, 3, 4 columns as well, and 2 rows. Okay, but then we have an algebraic expression for one of the values here. So here, see, let's go ahead and do one at a time. So we have in row 1, column 3, we have a value for x. Okay, and this should be equal to whatever is in row 1, column 3 as well. But here, again, they gave us an algebraic expression that says it's 2x plus 5. So in order for me to solve for this, I need to solve for x, yes? So this is my expression for the x. This is my expression for the y. Again, here I want to find the element that is in row 2, column 3. The element in row 2, column 3 is a 16. So this has to equal to this algebraic expression, 5y minus 4. So now we can just use algebra to solve. Okay, on this particular one, we're going to subtract 2x on both sides. So x minus 2x is a minus x, leaving me with 5, multiplied by a -1 on both sides. So x equals -5. How about this one? Let's isolate the y first. So I'm going to add 4 on both sides. So 16 plus 4 is 20. So to solve for y, I'm going to divide both sides by 5. 5 divided by 5 is 1, giving me the y. And 20 divided by 5 is 4. So the values of x and y for these two examples are -5 for x and y 4 for y. Okay. Any questions? All right. How about this one? Okay. Solve for x equation. Thank you. Where A is this 2 by 3 matrix and B is another 2 by 3 matrix. So we're solving for x. So let's do it piece by piece. Okay. So the first thing we want to do is let's get 2a. So we have 2a. So we know that this 2 has to be multiplied to all of the elements in matrix A. Okay. So this 2 for B says that we have to multiply this 2 to all the elements in matrix B. Okay. So when we do that, when we multiply 2 times -3 gives me a -6, 2 times 2 is 4, and so on. Again, over here, 2 times 3 is 6, 2 times 2 is 4, 2 times 3 is 6. Okay. Now that we multiplied our scalar multiple to our matrices, now we can add the matrices together. Again, these are the same size matrix. Okay, this is a 2 by 3 with a 2 by 3. That means I can add them together, and it's element with element, corresponding element. -6 is my row 1, column 1, needs to be added with row 1, column 1 of the adjacent matrix, right? So -6 plus 6 is 0. 4 plus 4 is 8. 6 plus a -10 is a -4. -4 plus 10 is 6. 0 plus 0 is 0. And 8 plus 4 is 14. So x is equal to 0, 8, -4, 6, 0, and 14. So be very careful also on the computer. Make sure you put these in the right order, okay? All right, how about this one? I'll give you guys a few seconds to set it up, and then we'll go through it. I think you'll find matrices very easy and useful, right? I hope. So here you see we're solving for x. So we'll have to do a little bit of algebra. So let's go ahead and do our solution, okay? So this is what they want us to do. 4b is equal to a -2 times x minus 2a. So the first thing that I'm going to do is to make my life a little bit easier. Let's solve for the x. So I'm going to move this element that has the x to the other side by adding 2x on both sides. This 4b to this side by subtracting -4b on both sides. Gives me 2x is equal to minus 2a minus 4b. Now to solve for x, I'm just going to divide by 2 on both sides. So x is equal to -a minus 2b. Okay, so we've done this process before. Okay, this means that I'm going to multiply a -1 to matrix A, and I'm going to multiply a -2 to matrix B. And when I do that, okay, these are my values. Again, I can add these two matrices together because they have the same dimensions. This is a 2 by 3 with a 2 by 3. That means I can move forward and add. So when I add these two matrices together, I have 2, -5, 3, -5, 0, -10. Again, these are the values that go here. The 2 goes here, the -5 goes here, the 3 goes here, the -5 goes here, the 0 goes here, and the -10 goes here. Okay. All right. So now that you know how to do addition and subtraction of matrices, now let's look at matrix multiplication, which is a little bit more complex. Okay. So in order for us to multiply two matrices together, we have to have the same number of columns from the matrix A equal to the same number of rows in the matrix B. Okay. So in order for us to multiply two matrices together, we have to meet this condition. Okay. The number of columns of the first have to equal to the number of rows of the second. Now, this is a little bit more information that the book gives you, that the resulting matrix, the answer of multiplying these two matrices together, you can get the dimensions by the rows of the first with the columns of the second. That's what's going to give you the dimensions. Okay, so the two best look at this is, let's look at an example. Okay, so here on this particular problem, I have this row matrix. This is 1 by 2 matrix. Okay, this is a column matrix. This is a 2 by 1 matrix. So again, in order for us to be able to multiply these two matrices together, the columns of the first have to equal to the rows of the second. These two have to be equal, and they are. These are 2 by 2. And when I multiply these two matrices together, my resulting matrix is going to be a 1 by 1 matrix. This is going to give me the size. Okay. Again, you know, it's not crucial information, but it's nice to know. Yes. So let's go ahead and do this. So let's multiply. So the way we multiply matrices is row times column. Also, the dimensions tells you how you're going to multiply two matrices together. So, which is what I talked about right now. So it's going to give me a 1, 2, 1 matrix. Okay. So here, when you multiply matrices, is row times column. Okay. So we have row 1, column 1. So 4 times 1 is row 1, column 1 gives you the answer for the address 1, 1. So we have 4. Okay. And then we have row 1, column 2. Okay. That's row 1, column 2. So that's going to be 1 times 2 is 2. So my matrix, the answer is the 4 plus 2, which is 6. And again, it gives me the 1 by 1 matrix. Again, to multiply matrices together is row times column. Okay. All right. Let's go backwards. Can we multiply these two matrices together? Okay. So this is a 2 by 1 matrix. This is a 1 by 2 matrix. So this means that I can multiply these two matrices together because the columns of the first equal the rows of the second. These two are equal. And my resulting matrix is going to be a 2 by 2 matrix. Okay. So let's go ahead and do this. Okay. We're going to do matrix multiplication is row row by column. Okay. So let's do it first. 1 times 4 goes here. It's address. Row 1, column 1 goes in the address of row 1, column 1. Okay. Then we have row 1, column 2. That's 1 times 1. So that's the address. Row 1, column 2 goes here. Now we don't have any more columns. So then we go to the next row. Row 2, column 1. Again, that's address. Row 2, column 1, that goes here. That's 2 times 4. Now the last one, row 2, column 2, that's address 22, that goes here. So that's 2 times 1. So we have 1 times 4 is 4, 1 times 1 is 1, 2 times 4 is 8, 2 times 1 is 2. And again, our resulting matrix was a 2 by 2 matrix. Okay. All right. Now, I like this one to show because for whatever reason, it confuses some students, right? It says find a squared. Well, what does this mean? What this means is I want to multiply A with itself. I'm just going to multiply the same matrix twice. Okay, so the way I write this out is matrix A is 3, 1, negative 1, 2. It's being multiplied twice, so it's going to be again 3, 1, negative 1, 2. Again, I can multiply the squared matrix. Again, squared matrix means that they have the same number of rows with the same number of columns. Okay, so this is a 2 by 2 and a 2 by 2. Again, these two numbers are equal, and my resulting matrix is going to be a 2 by 2 matrix as well. So let's go ahead and do this one. Okay, so when I multiply, again, row times column, row 1, column 1, 3 times 3, row 2, column 2 is 1 times negative 1. Again, row 1, column 2, then row 1, column 2, give me these values. Again, row 2, column 1, negative 1 times 3 goes here. 2 times a negative 1. Okay, then the next one, the last one, row 2, column 2, negative 1 times 1, 2 times 2. Okay, so when I add these, okay, I get 8, 5, negative 5, 3. Again, please don't let this throw you off. Okay, a squared means we're just multiplying the same matrix with itself. Okay. All right. So on this particular one, it says solve the following given matrices. Okay, B times A. So can I multiply these two matrices, B times A? So let's see. This matrix A, B is a 2 by 2. So let me do this. Let me write it over here. B is 2 by 2. Okay. Matrix A is a 3 by 2. So this was matrix A. Can I multiply these two matrices together? If you see here, these two numbers are not equal, so then our answer would be impossible or cannot be done. Yes, because they don't match. All right. I think that's all I have time for today. If you have any questions, please, I invite you. We have awesome tutors that if you want to stick around, that can help you review more matrices, how to multiply them. If you saw, we didn't get to do division of matrices, but division of matrices is very special, and we'll cover that next week. Okay, division of matrices is really called the inverse of matrices. So we'll see that next Friday. Okay, thank you all for joining us. Don't forget to do our surveys in the site. Also, you want to click on the links to get credit with your teachers if they're giving you extra points for attending these sessions. Again, thank you all and have a good weekend.
Thank you, Mr. Carizales, for your presentation, and thank you all for attending. We hope to have you with us for next week. I'll be stopping the recording now.